Alrighty, in the other class I did a kind of a revision video and we discussed Platonic solids. So here I'm showing you on Maths is Fun the 5 Platonic solids. We have a tetrahedron made of 4, 1, 2, 3 and one behind it. I can show you the net of a tetrahedron's like that. It folds up. So there's 1, 2, 3, 4 equilateral triangles. We can spin a tetrahedron. So there we go. I'm going to put it as glass. And yeah, so that's a tetrahedron made out of 4 equilateral triangles. That's the first Platonic solid. The next one's a cube. So there's the net of a cube, which means if you had that and you fold it up, you get your cube. And here we're going to spin a cube. And that's made up of squares, because squares are a regular shape. Each angle is 90 degrees and each side is the same length. And out of that regular polygon, a square, you can actually make this hexahedron or cube. So the next possible Platonic solid is an octahedron. So we have 8 equilateral triangles. So this shape has got a very cool amount of symmetry in it. Whichever way you put it, it kind of maps onto itself, if you like. So how can I explain that better? If I just stop for a minute. If you look at that side there, the triangle facing us, if I put any of the triangles there in that same position, whichever position that was, the shape can be seen exactly to fill in the same space. It's I'll find a better explanation of that in a minute. Anyway, my favourite, the dodecahedron. You actually take a regular pentagon and you use 12 of them to make this dodecahedron. So if we look at the spinner dodecahedron, and I'll put the glass one there, you can see, I'm trying to explain, if I put on the ground one of the, so imagine on the, yeah, you've got the pentagon there. If you put any of the pentagons there in that same position, the shape would fill the exact same space. It's got that much symmetry in it. There's only 5 of them. And the icosahedron, 20 equilateral triangles. So you can see the net of that. That if you did that and glued it up, you would get the icosahedron. Okay, so you can make them. Why only 5? All right. Simplest reasons, angle at a vertex. There's only 5 because here they need to add up correctly. That's getting a bit high tech, I think, for year 9. Yeah. We'll ignore that. So hopefully this is a better explanation. A Platonic solid is a 3-dimensional shape where each face is the same regular polygon. The same number of polygons meet at each vertex. So each face is the same size square, in this case, and 3 squares meet at each corner. There are only 5, and those are our 5. Okay, you can make the models and you can see animated polyhedron models. Took a while to load, but there you go. So there's the net. Solid, solid, net, explode, and spin. And now here I can drag it. Okay. Yeah. I won't explode them. I'll put them back like that and I'll make them glass. So these ones aren't Platonic solids, are they? Because they don't have that same thing. They're just different sorts of three-dimensional mathematical shapes. Which are pretty cool. It's usually at the end of the year that we actually make these kind of models. They're kind of cool. Some of them are quite complex, aren't they? And you can make one yourself. So you can choose any of those and make one. You can see more images of polyhedra. Oh, I love those. How about that? The beautiful world of maths.